And now we move on to Dr. Satish Thampi. You are connected with the payload PAPA. Already the plasma particles on the moon are analyzed. How do you analyze plasma particles in the sun? And what is the importance of solar winds and how does it impact?
Thank you. Thank you for giving opportunity to come into this show. As my colleagues, they mentioned actually about the sun. Today we have the auspicious day where actually we are going to our own star, that is the sun. Just I want to tell to the viewers that actually the sun, which is our hero basically in the solar system. If you look into the mass of the solar system, 99% of the mass of the solar system is occupied by sun. And also this sun is plasma. Now when we are talking about the heliosphere, actually with this all our planets are engulfed in that thing. You know, we have been studying in decades, maybe in centuries, we have been studying about the sun. But what we are lacking actually a comprehensive approach, because sun is giving its energy mainly in three forms. The first one is the radiation, actually my colleagues already talked about, which we can do remotely from our ground. But the plasma, basically we are talking about the solar, what we call the space plasma, as well as the magnetic field. This can be only studied by in situ. If we study all these radiation, particles and field, then only we will get a full comprehensive understanding of the sun. Now, we are getting the first space-based observatory from the Indian soil, and we are making this opportunity. And of course, I am thankful to ISRO and all my colleagues and my teammates from VSSC and all my scientific colleagues here. This is the opportunity we got actually. We are trying to understand actually all the three things: radiation, particles, and field. Already they mentioned about the radiation. Now, Dr. Bibin will be talking about field. Just I want to emphasize on the particles. That's why we named it as PAPA. PAPA means Plasma Analyzer Package for Aditya. This is developed by Space Physics Laboratory in support of Vikram Sarabhai Space Center. And now this instrument has two components. If you look at the solar wind, basically it comprises of 95% protons, then alpha particles roughly around 4 to 5%, then equal number of electrons also. So our PAPA is a comprehensive package measuring both ions and the electrons. Now these electrons, like already our colleagues they mentioned actually the major transition events like coronal mass ejection. That's a huge mass which is coming out of sun. Basically it's a plasma. Basically when we are talking about solar and basically nothing but it's the extension of the corona only. That's the atmosphere of the. Now these particles actually they only actually modulate the energy and momentum of the planetary atmospheres. See when then sun is quiet, like he is not aggressive, sun is what we are getting the ambient solar wind. So if you look into that thing actually, that one actually gives what we call about the interactions, what we call the normal routine phenomenon which is happening on the earth. But when there is sun is angry, it gives like in a CME, CAR or these sort of events are happening, that is really going to affect our planets. That's what we call the space weather. Now our intention is to understand first of all actually what these effects, basically the solar wind in the ambient condition as well as during this transition events, how this solar wind behaves, and also how this coronal mass ejections which is passing through different planets, how actually what are the different things like what we call about the microphysics, macrophysics and the mesophysics of that things that we want to understand. So one thing is actually it's a physics subjective to understand because we are getting an ideal point, Lagrangian point, which is in the sun-earth plane, and we will be seeing the events exactly there. Second thing is actually we can definitely monitor the parameters. Like what actually PAPA will measure electrons and ions, we will be getting energy, direction and angular information, mass information. So if we know these things related to electrons we don't want the mass, but for the ions we are getting the mass information. Okay. Coupling all this information actually what we can do is we can derive the plasma moments. That will be definitely going to the modeling part, actually dynamics part, and that will definitely going to tell about the effect of the space weather effects.
Yes.
So in due course actually with the L1 in addition to other L5 missions we will be able to tell. This is the importance of the plasma missions.
Yes.
That actually as you mentioned actually earlier with the lunar mission we tried to understand that thing. Really it changed, this plasma studies changed the perspective of the moon. Now Aditya will give more detail about it.
Yes.
Thank you.
Thank you, sir. Thank you so much for that, sir. And now we move on to Dr. Dipankar Banerjee. So you manage the beautiful solar observatory at Nainital. How do you think the studies of heliophysics will supplement Aditya L1? Can you tell us something about the history of solar observatories in India?
That's right. India has a long tradition of looking at the sun from the ground. In fact, from Kodaikanal Observatory, we have been observing the sun for more than 100 years. And also we have beautiful, solar observatory at Udaipur, in the lakeside, and at Nainital. We are looking at the sun. But there are limitations of looking at the sun from the ground because you can only see the lower atmosphere of the sun. So this was very, very important that we could go to the space. And this is a fantastic opportunity. Originally, more than 10 years back, we were only looking at a small satellite program. And then Professor U.R. Rao suddenly came up with this idea, why are you be taking baby steps. We should think big. We should go to much longer distance. And then this opportunity came in, the Lagrangian 1 mission. The entire country, all the scientific institution got very much highly motivated. There are multiple payloads were then proposed. So eventually now we have a Lagrangian 1 observatory class mission. And as you heard from my colleagues, that it is a multi-wavelength observatory. So that's very important to have the shorter wavelength coverage from the space. And in addition, the ground-based observations are also important. So a combination of the ground-based telescope and the space-based platform is very, very important. And since you asked about the question about the, how Aditya in the overall heliophysics research within the international scenario, we only have 3 spacecraft around Lagrangian 1 point primarily from NASA and ESA. So I think again this is a fantastic achievement from India. If you could reach L1 with the full observatory class mission, it will really open a new window altogether. So I think this is a great opportunity and we are all looking forward. And as I mentioned, probably we'll request that, a better ground-based facility. We have already projected a National Large Solar Telescope project from the ground. I think this is now high time we have a very nice ground-based telescope also to complement the capabilities of Aditya L1.
Thank you very much, sir. Indeed, it's a very great opportunity. And now we move on to Dr. Vipin K. Yadav. So you're in charge of the magnetometer. What is the contribution of magnetometer to Aditya program?
You see, the magnetic field measurements are very crucial in space and especially at L1 point. What we are going to measure with magnetometer is the interplanetary magnetic field that is coming all the way from Sun and towards the Earth. So typically these values at L1 point are around 5 to 10 nanotesla. But these values increases whenever there is an extreme solar event such as the coronal mass ejection or say a solar magnetic storms. Now these events are crucial to monitor the near Earth space weather because these can have an effect on the life on Earth. If you remember Quebec, there was an event when the power lines were snapped a few years ago. That was because of an extreme solar event. So to keep an eye on the surroundings of Earth, we need these measurements, and apart from that, for solar wind observations also, these measurements will be crucial. Thank you.
Thank you very much, sir. So now we move on to Dr. Anuj Nandi. So what is the importance of solar flares and the impact in heliospheres? And how does Aditya L1 contribute to all of this?
Good afternoon, viewers. As my colleagues already pointed out the importance of this mission and the instruments about. So the thing is, as you know, that solar flares are the energetic and explosive energy release in few seconds to minutes time scale, and it is order of 10 to 27 arcs to 10 to 32 arcs. Now the thing is, these solar flares, why it is important as because the solar flares actually tells the dynamics and activity in the sun. So the thing is, there are 2 unique instruments built by URAO Satellite Center that is going to cover the solar flares from 1 kV to extremely high energy around 200 kV. And we know that visible sun is only 6000 degree Kelvin temperature, whereas the outer surface of the sun is million degree Kelvin. So the thing is, why there is disparity? So I think these 2 instruments along with the other 2 instruments VLC and SUIT, we are going to address this $1 million questions as well as why there is difference. Thank you.
Thank you very much, sir. And now I'd like to go back to Dr. Anil Bharadwaj. So there are many satellites that are sent to the space by other nations. So what makes Aditya L1 different from these satellites?
Well, that's a very good question because first of all, let me again tell you that India will be the third, or ISRO will be the third space agency to have a mission at L1 point. And I just mentioned that it is multi-wavelength, multi-instrument and multi-direction, and it measures particle, field and radiations. So you don't have such kind of satellites existing at L1 point so far and currently. That makes Aditya L1 absolutely unique because we are going to measure remotely, in situ and particles and fields.